everyone. This video is about some more signaling. We've got the PI3, the phosphatidylinositol 3 pathway, and the JAK STAT pathway. Okay, so start out with our PI3 pathway. So PI3 is, I'll write it up here, our phosphatidylinositol 3 kinase. So it's a mouthful. Phosphatidylinositol 3, or you could just say PI3 kinase. So we know it's going to phosphorylate things. Signaling. Okay. So we'll start out just like we did for all the other ones. We'll draw ourselves a nice membrane. For this one, it's important, we're going to talk about the two leaflets of the membrane, so I'm just going to the other ones, it was just assumed it was our normal double bilayer membrane, but this one we're actually going to draw it out, okay? So we've got our normal membrane in the cell, and then our receptor here. Okay, so this is a good, strong example of a receptor tyrosine kinase. And that means that the receptor has its own kinase activity. So same thing happened with the RAS-G protein. Remember those tyrosines phosphorylated, and it was all because of the action within the receptor itself. So we'll write that off to the side here. It's an example of a RTK, right? So receptor tyrosine kinase. Okay. So we've got some tyrosines. I'm just going to draw little dots to represent tyrosines. Remember, that's a type of amino acid. So when we get something, whatever the signal is, that's going to come and bind to the receptor, so that's our little ligand, then that is going to cause the receptor activity, like activity within the receptor. There's kinases within the receptor that will add a phosphate to each of those tyrosines, forming phosphotyrosines. So these are phosphotyrosines. Okay, so when that happens, our PI3 is going to come in. That, I don't need to write it out again, it's right here, phosphatidylinositol 3. So PI3 is going to come in and bind to these phosphotyrosines, and that's going to activate it. So PI3 is a kinase, right? So it's going to go and phosphorylate something. So over here in the membrane, the reason why I drew two layers of the membrane, in the inner leaflet of the membrane, we've got PIP2, right? So that is our phosphatidylinositol diphosphate. He most likely is just going to use abbreviations. He likes to do that. But in case you need to know it, phosphatidylinositol, so PI, and then diphosphate, two P's, two phosphates, right? So our PI3 is going to come in and work on PIP2, and that's going to add a phosphate and turn it into PIP3. Still in that inner leaflet of the membrane. So that turns into PIP3, and that is going to go and is going to activate protein kinase B, which is also called AKT. What color should I use? We'll use this one. So we've got AKT over here. So PIP3 is going to come and activate AKT. Okay, AKT is also called protein kinase B, we said. And we know that kinases phosphorylate things, right? So AKT is probably going to go phosphorylate something. So also the next, so our next step, AKT is going to go and phosphorylate something called BAD. BAD is actually a good thing, so it's a funny name, but we'll just do a circle. So protein kinase B is going to go and add a phosphate to BAD, and that is going to cause cell survival. BAD is going to promote cell survival. That's our end product of this pathway. So that's good. And then to turn off this pathway, we've got something called PTEN. So PTEN, he's going to come in and he's going to go and reverse what PI3 did. He's going to come in and dephosphorylate this and change it back to PIP2, and that will turn off this whole pathway so that we're not getting this cell survival. Okay? Let's go to the next one. So I'm going to erase this. Where's my eraser? Sorry about the lighting in my apartment. It's kind of not the best. So hopefully you can see all right. Okay. Our next pathway. Let me put the caps on all these markers. Okay. Our next pathway, there it is. We said is our JAK stat pathway. Now, let's just write that out first. So our JAK stat pathway. Stat. So the PI3 that we just did was a receptor tyrosine kinase. So the tyrosine, or the kinase activity is within the receptor. JAK-STAT pathway is an example of a non-receptor tyrosine kinase. So that means that something outside of the receptor, something else is going to have to phosphorylate the tyrosines on that receptor. So this is a non-receptor tyrosine kinase. Okay, so we've got our membrane, receptor. That is awful, sorry. Okay, make it a little longer. So got our tyrosines, per usual. Those are tyrosines, just pretend with me. So, like we said, this receptor does not contain its own tyrosine kinase activity. So JAK, aka Janus kinase, is going to come in and it's going to phosphorylate the tyrosines for the receptor. You could, you know what, sorry. Technically that should all be in caps, but it's the same thing because it's an abbreviation. Okay, so that's going to come in and phosphorylate the tyrosines on the receptor because the receptor can't do it itself. Okay, so when that happens, we're forming those phosphotyrosines just like before. phosphotyrosines. And JAK stands for Janus kinase. So it's a kinase, right? It's going to phosphorylate things. That makes sense. So JAK-STAT is going to activate the receptor, making phosphotyrosines. And then STAT is like, hey, I want to be phosphorylated too. I want to join the party. So STAT comes in. And JAK is like, okay, while I'm at it, I'll phosphorylate you too. So it does. Adds phosphate to STAT. That's a P. Okay. So we know that, just a side note, STAT is an SH2 containing protein. He likes those little details. Remember our GERB2? Let me double check on that. Yeah, GERB2 from the RAS-G protein signaling was a different SH2 containing protein that we talked about earlier. So anyway, so STAT is an SH2 containing protein. JAK is going to phosphorylate STAT. And we're not just going to phosphorylate one STAT, we're going to phosphorylate lots of STATs. So eventually we're going to get enough that two are going to come together and form a dimer. So we're going to have STAT1 and STAT2. Those are supposed to connect. There we go. Okay. STAT1 and STAT2 are going to come together. There's more than two, but you know, they're two at a time are going to come together and form a dimer. Okay, so when that happens, then this like whole dimer together moves to the nucleus, and then we get a cellular response as the end of this pathway. So that cellular response is going to influence gene transcription. Okay. Yeah, so that's the end of that one. Side note, also, so I should have said this earlier, sorry. So STAT, this might help you remember. STAT stands for signal transducers and activators of transcription. So that makes sense because the end goal is going to be to influence gene transcription. So signal transducers, and that's an and sign, activators of transcription. Cool. And that's all. Those two are pretty quick. I realized I never drew something up here, sorry. Something attaches to the receptor to start this whole process. Cool beans. Let me know if you need any help, and happy studying.